For the display connector, we're going to add a 1x14 connector, and this is going to be a right angle male header. It's got 14 pins. We have 13 LEDs and then one for ground that we're going to connect to the LED display. Also on the display, we're going to have just the LEDs lined up, and we're not going to have any resistors. This is so that we can make it as pretty as possible without anything extra in the way. And we're going to put all like the cluttery stuff and all the real heavy lifting on the control module. So what we're going to need, we're actually going to need some resistors. So let's go add resistor. I want to add 10K resistors. However, you're more than welcome to change that to be whatever size that you want or need for your project. I'm going to use this through hole 2047. The 204 means that the body of the device is 4 millimeters, and the 7 is the lead spacing. Cool. And I'm going to kind of stagger them so that they're not in the way of each other. And we're going to put a resistor on every single pin except for the ground pin. Let's go add our ground now. We might need to change the style back to continuous. And then we're going to connect these. And then here we're going to make more connections, and then as you're going to guess, we're going to make labels for them right after. Alright, let's go ahead and actually give these some names. So the way we're going to name it, and it's going to be hard to imagine here, we just need to make sure that on the display module we match it up. But I want to name them by our most significant digit and then which LED weight it has. So this is going to be 1. And then right above it is going to be the 2, so our most significant 2. So that's one column, and then the next column we're going to do 4 more, and they're going to be the least significant digit. And it's going to start at 1, and we have 2, and we have 4, because the weight of that LED is 4, and then 8. And then we're going to do the same thing for minutes, starting at the most significant digit, so we're in the third column now. So I'm going to cheat and just kind of go back here, change it to minute. The minute column is going to have 1, 2, and then 4. And then the least significant digit is going to have all the way to 8. So 1, 2, 4, and then 8. And this will become more clear if it isn't when we do the LED display. And now we're going to want to name them to their respective pins here. So let's go ahead and do that. So it's going to seem a little random, but that's because I'm going based on what I've had working in my model. So I'm going to name this one minute least significant digit 1, minute least significant digit 2. This is going to be our least significant digit 2. It's going to be our least significant digit 1, our most significant digit 2, our most significant digit 1. Oh, I lied. We're not actually connecting this pin nor this pin. This is going to be SDA or serial data, and this is going to be serial clock, but we'll name those when we add the RTC. Then we're going to name this minute least significant digit 8, minute least significant digit 4, minute most significant digit 4, minute most significant digit 2, minute most significant digit 1, our least significant digit 8, and then our least significant digit 4. Alright, so we have all our LEDs connected here, or technically they're just the resistors. So what's going to happen is that the ATtiny is going to be connected here. It's going to go through the resistor to the connector, and then the connector is going to connect to the connector on the display, and that will go straight to the LED. Alright, let's box this guy up. And then let's title this, it's going to be going to the LED display. So we'll call it LED display connector. Perfect. Next, for the real-time clock, we're going to use the DS3231. So you can do add DS3231, put a star, and we're not going to be using the surface mount. We're going to be using one that's going to be connected to a header pin. So we can use this one. Alright, let's place it maybe right around here, and we're going to need to power this guy, and of course we're going to need to ground it. So let's add ground, and then let's add our 3.3 volts, and then we're not going to connect the 32K and the SQW, but we are going to connect I2C. This is how we're going to communicate with the clock, and the SCL, and the SDA, and then similarly we need to connect it to the ATtiny. So if we look here, MOSI, digital in, or data in, and then SDA, so this is our serial data, so we'll name SDA for this guy. And similarly, this is SCL for serial clock. Great, so we have all our pins connected on the ATtiny. We have our real-time clock connected, pretty easy on this guy. We're going to box it. And we can name it whatever we want. Let's do RTC DS3231. Last thing we need to add is just the power system.